For decades, software has rested on determinism. You provide a specific command, and the machine executes a linear process to deliver a predictable, repeatable output. Generative algorithms and large language models deviate from this logic. Instead of executing rigid code, they calculate statistical weights across billions of parameters, operating on probability. Because these systems predict sequences rather than retrieving fixed data, they produce hallucinations, false or anomalous outputs that are a byproduct of their probabilistic reasoning. Users accustomed to traditional, highly resourced corporate structures often struggle with these anomalies. When a tool fails to provide a deterministic answer, the resulting friction typically leads to the system being abandoned. Thriving in a non-deterministic environment requires an abandonment of linear expectations. The chaotic nature of the AI ecosystem favors a specific type of cognitive agility. Interfacing with these algorithms effectively requires biological prompt engineering, a psychological disposition focused on real-time improvisation that treats imperfect outputs as raw material for iteration. We can observe this disposition within the South African Afrikaner community. They transitioned from isolated pastoral origins into the creators of a sophisticated industrialized state. The foundation of this survivalist trait is the cultural heuristic, a Boer maak a plan, or a farmer makes a plan. It emerged on an agricultural frontier where geographic isolation necessitated immediate, pragmatic solutions. Over centuries, repairing equipment with limited resources evolved into a broader philosophy of adaptability. It represents a rejection of systemic constraints in favor of human agency. This historical focus on forcing functional solutions out of raw scarcity provides a potential framework for navigating the Fourth Industrial Revolution. If a culture is conditioned to repair a broken system rather than waiting for perfection, it possesses the resilience needed to manage algorithmic chaos. We map the cognitive requirements for AI by comparing deterministic and improvisational mindsets. When AI hallucinates, deterministic thinkers view the anomaly as system failure and halt. The improvisational mindset views it as alternative data, iterating fragmented tools to forge an immediate solution. This approach serves as a bridge between the theoretical capabilities of a neural network and the practical, often unforgiving realities of the physical world. The improvisational mindset doesn't just tolerate algorithmic errors, it treats them as the raw material required for rapid, localized problem solving. This mirrors vulture opportunism, extracting value from decaying systems. In South Africa, this means municipal collapse and unstable power grids. Instead of succumbing to state failure, Afrikaner civil networks use AI as a scavenging algorithm, routing data directly into independent, functioning architectures. In the agricultural sector, farmers utilize large language models to navigate a 6-year backlog for vital medicine registrations under Act 36. They use the technology to interpret obfuscated regulations and structure complex compliance documentation. With traditional support structures absent, AI serves as a baseline requirement for administrative survival and legal compliance. An institutional example of this ethos is the High-Sci AI platform, developed specifically for family farmers by the Southern African Agricultural Initiative. The platform is built on pragmatism. It compresses a database of 13,000 agricultural topics into a low-bandwidth WhatsApp interface. The system provides actionable advice in 83 languages, filling the vacuum created by a severe shortage of human experts. During local crises, from water contamination to sourcing alternative fertilizers, the AI serves as an immediate advisor, substituting for a lack of formal state extension services. As users across the country engaged the system, an emergent property appeared within the network: algorithmic biosecurity. By analyzing the frequency and geography of user inquiries, the AI successfully predicted a localized foot-and-mouth disease outbreak before official government agencies detected the threat. This indicates that when computational power meets localized pragmatism, decentralized tools can outperform centralized government monitoring. This improvisational agility scales into a broader institutional framework known as staatsbestandheid, or state-proofing. State-proofing involves the construction of legally compliant, privately funded civic infrastructure, essentially a functional parallel state. Integrating digital platforms like Nile and Kula creates a mesh network of supply chains, operating entirely independently of the failing state. Venture capital networks that previously operated in legacy industries are now funding this disruption, prioritizing the transition into global technology and consumer internet sectors. Within this framework, artificial intelligence functions as a tool for engineering institutional sovereignty, providing a layer of economic protection for a politically marginalized community. This high level of integration occurs alongside a philosophical resistance to the idea of human obsolescence. According to the 2026 Human 8 Trend Report, 81% of South Africans believe human creativity and craft possess more value than purely AI-generated content. The result is a dual approach. The community uses AI for maximum operational efficiency while fiercely defending human agency in journalism, language preservation, and storytelling. This mindset views AI as a powerful utility to be scavenged for parts, rejecting it as an infallible oracle or a replacement for human judgment. Traditional technology deployment often falters by waiting for pristine data and stable infrastructure in environments that are perpetually unpredictable. The Boer-maak heuristic converts unpredictability into an advantage. By scavenging value from chaos and fragmented tools, it consistently engineers functional solutions. The localized drive for independence suggests a functional model for navigating technological volatility on a global scale. As the digital frontier becomes increasingly non-deterministic, raw processing power is secondary to biological prompt engineering. In the age of algorithms, sociological elasticity is a primary driver of strategic autonomy.